My name is Scott Holstein. I'm the Director of Marketing and Business Development at Computrols, where I've been for the last 5+ years. One of our big pushes for the sales and marketing department is providing educational content like this. So speaking at these kinds of conferences, and we put on regular webinars, we try to write articles, create infographics. I host the Building Technology Podcast, which is an educational podcast for facility managers on all things smart buildings. And then I'm joined by my colleague Mike, who's been working with Computrols for 20+ years. And there's not much Mike doesn't do with Computrols. He helps me out on the sales and marketing side of things quite a bit, trying to simplify things for not only me, but our internal team, our customers. And then, he's also extremely technical, so you'll see Mike helping out our R&D team. He's a great resource in terms of what's coming and what's the latest and greatest technology. And then Mike's main role with us is he's our manager of strategic partnerships, working directly with our distribution partners who resell, install, and service Computrols products. And not to spend very long on this, but just a brief introduction so you have a little bit better idea of Mike and I's background. Computrols is a manufacturer of building automation systems. We've been around for 30+ years, and what we're best known for is reducing the long-term cost of building automation systems. So a couple of the ways we do that is by providing lifetime warranty controllers. We have a very user-friendly system that we give the same access to customers as we do our own technicians. There's nothing really held back, no special passwords or anything like that. We also provide free remote tech support. Ultimately, we want to help you operate that system autonomously. And one of the other unique things is we manufacture our product in the United States of America, which is not all that common these days. So very proud to have been working with Computrols for the last 5+ years. So what we're here to talk about today is taking existing buildings from smart to smarter. Now, you might be thinking, what's the difference between smart and smarter? That's gonna be one of the first things we address. So we're going to define what a smart building is, talk about what makes a building quote unquote smarter. We're going to go over the benefits of these buildings, talk about the challenges of what comes along with it, the technology behind it, and then ultimately we want to give you all the action items, some tools to walk away with to ultimately take your buildings from smart to smarter. As a part of the continuing education credits, we do have learning objectives that we're going to make sure we hit today, which is defining what a smart building is, understanding the features and benefits of these buildings, identifying ways to take a building from smart to smarter, and then learn how to ensure your facility is prepared to utilize future technologies. So with that said, let's get into the actual presentation here. So what makes a building smart? Smart building, as soon as go to Google and you start searching for definitions of smart buildings, this is one that'll come up. RCR Wireless News defines a smart building as any structure that uses automated processes to automatically control a building's operations, including HVAC, lighting, security, and other systems. So by this definition, smart buildings have been around for over 100 years. It was 1906 when a young guy by the name of Mark Honeywell developed the first programmable thermostat, which he incorporated a clock that allowed for him to preset the temperature for the following morning. So they've been around for a very long time. So chances are the majority of your buildings are already considered smart buildings. If your buildings use access control cards to let people in and out, you have a smart building. If you turn off the lights by a schedule after hours, you have a smart building. If you have an HVAC system that stops equipment when it reaches a set point, you have a smart building. And don't want to sound any more like Jeff Foxworthy than I already do, so you get the point though. The bar for smart buildings is not very high by definition. So that's why we want to talk about taking these buildings that do what we now consider to be pretty standard operations from smart to smarter. So how do we define smarter? And this is not a by-the-book definition. There is no real by-the-book definition, but some of the things that we're seeing in buildings today that we look at and we say, look, this is the the latest and greatest technology. This is a step up from where we've been. We're seeing a lot more integrated systems. So, for example, you might have access, HVAC, and lighting controls all integrated within your campus. So when your first faculty member comes and parks in your parking lot, and they swipe that access card to get into the parking lot, it automatically is going to turn on the lights on their floor, turn on the lights towards the elevator, and start the air handler on their floor. So rather than starting these systems automatically at the same time every day, regardless of whether anyone is there or not, you're now waiting until somebody is actually coming on campus. So, all those kind of minute, late starts, early finishes for these pieces of equipment can be huge for energy saving purposes. We're also seeing more self-optimizing systems using analytics. Artificial intelligence is figuring out how to run your building more efficiently without a whole lot of help these days. Some examples of that: there's now lighting where, of course, where everybody's trying to move towards LED lights, but beyond being more energy efficient lights, there are lights that are now on the network. They are nodes on your network. And so essentially they're internet connected. Some of them have occupancy sensors built in, so they know if somebody's in the area to turn on the lights. They may also have lighting sensors that are picking up how much natural light is coming into a building. So if you have an extremely sunny day and it's the middle of the day, you have plenty of light coming in, those lights now dim because they don't need to work as hard. So another example is what we're seeing a lot of is predictive maintenance and fault detection, where these systems are able to identify anomalies in the way equipment is running to raise a flag for facility managers and tell the facility manager, look, something's not right here. Go check out this piece of equipment. And it's getting to the point where they start to learn how that equipment's supposed to function, and based on how it's currently functioning, they may even be able to identify what piece of that equipment may be failing or starting to malfunction. We see smart elevator cabs. So destination dispatch is becoming more popular. So if you have 5+ floors, destination dispatch is not a bad idea. But what you get with that is instead of going to the elevator and pushing the up button, you're going and pushing the button for your floor. And based on everybody in that elevator corridor there, where they're going, it's going to assign you a cab based on what's going to be most efficient for that elevator and for the people who are riding to get you where you're going. One of the other really popular ways to interact with buildings now is hot desking. So we see this a lot in the commercial sector, but I have a feeling that if it hasn't made it to higher education yet, it is on its way, where you actually have an app that before you come into a building, instead of having an assigned seat or coming in and looking around for a seat, you actually book that area on your desk. So you book a meeting room, or you'll book a table for 4, or you'll book a cubicle. And beyond being able to reserve that space, it may also have saved settings for the temperature of the lighting, the temperature and humidity of the space. Whatever your saved preferences are, it's a much more personalized experience. We're seeing a lot more people counters now, particularly with the post-COVID world. People counters are looking at how many people are in a specific space. You may even have something for students that tells them, look, the rec center has so many people in it at the moment. Or instead of identifying exactly how many people, maybe you have some kind of indicator of empty, crowded, and packed, or something like that, where now if I'm considering going to work out at the rec center, I'm going to go check my app before I go there just to see how crowded we're talking it is. Even bus routes. Students who are getting on buses. Now buses have built-in GPSs, so they're not standing at the bus stop any longer than they have to be. So we're starting to see this all over the place, and this smarter building and smarter campuses are becoming more and more common. So let's talk about some of the benefits. And some of these may seem obvious and maybe some less obvious. Increased productivity. So we talk about productivity in a few different ways here. Productivity from a building occupant standpoint. There have been numerous studies out there that have proven that under the right conditions, people are actually more productive. So in the right temperature between, let's say, 70 and 72 degrees, and under the right lighting and having enough fresh air in the building, people are actually more productive. And as people who are operating these higher education facilities, the end result of that is potentially improving learning outcomes. And a lot of these benefits are where, when you have to go to the powers that be within your universities, within your schools, you need to be able to justify what you're trying to do here. And these are all ways of doing that. So the productivity factor is undeniable. You also see studies that show that people are happier under the right conditions as well. And then maybe the most obvious benefit of smart campuses is going to be energy consumption reduction. So your pieces of equipment now are smart enough to figure out, okay, I don't need to be running nonstop, or I can run this way to be a little bit more efficient. VFDs have become really commonplace on major pieces of equipment, where instead of running full speed or not at all, these pieces of equipment now can ramp up and get to a place that they're running at peak efficiency. The energy consumption argument is a very strong one, because ultimately it reduces operating costs. So operating costs, of course, is inclusive of things like energy consumption, but what you have to start to consider is also your people, and that opportunity cost of, where in the past maybe you've had a facility manager who, a piece of equipment has failed. Now he needs to get in touch with the manufacturer. He needs to be on site and with the manufacturer when they come out and work on it. Maybe they fix it. Maybe they need to get a part to replace it. Now that facility manager has gotten a preventive maintenance alarm that said something doesn't look right here, and that they've gone out, they fixed the part before it failed, and saved hours upon hours of their own time. And so what oftentimes is not considered is, okay, my facility manager is no longer spending that time there, so he's getting to spend that time elsewhere where it is more valuable. And then from an operational perspective, we're now identifying larger problems with systems, where previously a piece of equipment would fail, and we'd look at that single piece of equipment and be like, well, what caused this? Now we can look at a much bigger picture and get a lot of information and meaningful information, where you can make decisions based on that, and reduce that operational cost, where maybe you're, like I said, not replacing a piece of equipment, you're just replacing a part. Then there is a better use of resources overall. So we use the hot desking example. We've seen a lot of examples of hot desking that are proving that you don't need as much space as maybe you previously did, when people are able to reserve spaces and go and work in open areas and things like that. Another example would be parking. So parking on college campuses, at least in my experience, is historically a pain. So for me, I look at all these smart parking examples now, and I'm like, oh, this would have been great. Where you have, when somebody drives into the lot, instead of circling around, they know that this one particular lane has 2 spots open on it, so they go straight to it. So what you're finding is from a space and resource standpoint, with smart buildings, you're not using as much. And then healthier and safer buildings. So pre-COVID, we paid attention to, we wanted the right amount of outside air coming in the building and things like that. But at the end of the day, if you had to prioritize items on how you were going to run your buildings, it was probably occupant comfort, energy efficiency, and then health and safety. Now, health and safety has become probably the top priority for the majority of you out there. And smart buildings have the ability to automate a lot of that. So you're automatically bringing in more outside air based on how many people are actually in the space. You can look at that. You can see how much CO2 is in the space. You can count how many people are in a given space. It's making buildings healthier for sure. And then from a safety standpoint, in the world we live in today, it's unfortunate, but we have to be aware of things like active shooters and any kind of event that's going to cause safety issue for your students and faculty. So with these smart buildings, you have panic buttons on the wall that'll lock up the whole building. You have the ability to do that at a campus-wide level by clicking a single button. Whereas, in previous cases, it was not that simple. And then we look at a more personalized experience. So we talked a little bit about hot desking and, a student having an app to see when the bus is coming and things like that. This generation that is coming up today, is in that range of your typical higher education student. They grew up with technology. They expect this, and it changes their view of your university and how they interact with it. So beyond those improved outcomes for the university, you're also looking at how students perceive the school they're attending. So we've talked about a lot of the benefits. With most technology comes some challenges as well. So with these smart buildings, with all this smart technology, you're going to get a more complex network architecture. That network architecture is expanding, and there are a lot more pieces to the puzzle. And because of that, you now have a different skill set that you're looking for to manage these complex systems. So you're doing usually one of two things. You're retraining current staff on these new systems and how they work, or you're hiring differently. You might be, instead of looking for your typical HVAC guy, maybe you're now hiring a data analytics professional. A lot of these services are fantastic, but when you're completely dependent on an outside vendor, they also become cost prohibitive at times where the cost outweighs the benefit. So having those people in-house to operate these systems can make all the difference in whether or not it's worth the investment. And then information technology departments are becoming more important than ever. We always tell our customers, get IT involved as early as possible. You don't want to get farther down the line and have to go to IT after the fact and say, oh, hey, we need 100 IP addresses for these devices, or you're asking for something that is going to take some time. So we always encourage people, get IT involved early, and let them help you. They are the experts when it comes to your network and making sure that this is going to be successful. So when I say early, I mean in the sales process early. If you're considering new technology, they should be involved in that sales process and provide specifications or get specifications from that service partner of what is required. And then security is paramount. It always is, but cybersecurity is such a huge topic these days. When you're talking about adding hundreds, if not thousands, of internet-connected devices to your network, it's a scary thought. I will say now that all of the manufacturers who are, or I can't say all, but the majority of manufacturers out there are spending a lot of time on the security, encryption, etc. of their products. So they're not giving you something that a student can log into the Wi-Fi and take over easily, but the more internet connected devices you have, the more exposure you potentially have. So again, the information technology team, along with just doing your due diligence and making sure that you're working with a service partner who has this thought in their mind as well of we need to continuously ensure that our cybersecurity is top notch is really, really important to this process. Now we're going to touch on the technology behind these, behind this push towards smarter buildings. And for a long time, we were seeing that new technology was always coming to the consumer market first. The large-scale commercial, real estate, or higher education, these large-scale deployments really came well after. I'm talking years after. But what we're seeing now is an intersection of cloud computing and connectivity that is pushing these things faster than it ever has before. So cloud computing, I know that the APPA audience is a sharp one. I don't have to explain what cloud computing is, but for the sake of being thorough, we're basically utilizing a bunch of interconnected machines or computers in data centers and accessing platforms remotely. Where historically we've always had these local devices where you have as much processing power as you have on your laptop or your desktop or your phone or tablet even. That's not the case anymore. If you turn your phone on airplane mode, you'll get to see just how dependent on cloud computing your phone is, and a lot of your applications on that phone are. If you ask Siri a question while your phone is in airplane mode, she's not going to help you. She is dependent. I say she, but the machine that is responding is dependent on that cloud computing technology that is likely going back to Cupertino at Apple headquarters, processing your natural language request, and then sending back the answer. It all happens so quickly, it seems like it happens at the device level, but frankly, it's really impossible with the way technology is today. And then artificial intelligence. Artificial intelligence has actually been around since the 1950s. But as a result of the advancements in technology and cloud computing specifically, we're starting to see huge strides in this field. And then, artificial intelligence is essentially just the use of computer systems to perform tasks that are typically performed by humans. And then machine learning is a branch of artificial intelligence which allows machines to automatically learn from experience without having to be explicitly programmed. So machines are now able to determine that, based on this hypothesis that they tested, they said we're gonna start this a little bit earlier. We're gonna do something a little bit different here, and we reduced energy consumption, or this worked. They have the ability now to kind of make those confirmations on their own. I use the example sometimes of Pandora. So Pandora, for those of you who may not be familiar, is a music app that comes on. I don't know if it still comes on every iPhone or not, but it used to. And it's an application where you tell it, hey, I personally I'm a big Taylor Swift fan, so I have Taylor Swift radio, and so they'll play a Taylor Swift song, and they'll give me the option to give them a thumbs up or a thumbs down. Well, I like Taylor Swift, so I give it a thumbs up. Next song comes on, it's a Justin Bieber song. Not a Bieber fan, so I give it the thumbs down. And now it's starting to learn what my preferences are. So it plays a Miley Cyrus song next. I like Miley Cyrus. I love Miley Cyrus. I give it the thumbs up again. So based on my input, it's starting to learn my preferences. And so that's a kind of a simple real life example of where you're seeing machine learning and artificial intelligence in your day-to-day life. And big data, man. This slide and the next slide, I'll tell you, are buzzword city. The buzz is loud right now, but it is important, and it is worth discussing. So big data, again, has been around for a long time, where you're collecting all of this information, and that's the beginning of how you create these smart campuses. Is you need to collect the data to understand how you can adjust your operations based on this information. So, like I said, big data has been around for a while, but advancements in artificial intelligence, machine learning, are allowing us to look at that information and pull out meaningful outcomes, as opposed to, if I as a human look at as much data as a computer is looking at, it's likely going to be meaningless. There might be a few things that I can pull through after spending hours upon hours of looking at the information, where a computer can go in, process that information in a matter of seconds, and say, look, these are some patterns that we noticed, look at these. And then, like the Pandora app, you give it the thumbs up or the thumbs down. That pattern may have been something that was unimportant. That pattern may be something that you really need to look at. So then we talk about connectivity, and I mentioned that this slide was also a big buzzword slide, the Internet of Things. So Internet of Things is still not really where people believe it is or want to believe it is. Internet of Things is essentially all of these different devices, regardless of manufacturer, regardless of the protocol of all these different languages these machines speak, that they're going to be able to share information in a meaningful way, and it's just not quite there yet. And one of the major challenges is the connectivity challenge. So we have some devices that are using Wi-Fi, some devices using Bluetooth, some devices are tagging certain pieces of data differently than others. And so until the manufacturers of a lot of these devices start to come together and realize there needs to be some common protocol, there needs to be some common language to be able to get these devices to speak, the Internet of Things simply won't take off the way that I think a lot of us dream it would. So some of the things that are driving the Internet of Things and connectivity in particular, we're seeing a ton more wireless communication. Whether it is a Wi-Fi, new standard of Bluetooth that is allowing now Bluetooth mesh, can now, devices that historically have been receiving messages only can now repeat messages and send messages themselves. 5G is a huge discussion right now. Another one that is, right on the cutting edge. Maybe not quite there yet, but certainly on its way. And then within wireless communication, there is what we used to call the power problem when we were developing some wireless products. Is, okay, if you want a truly wireless product, how is it going to be powered? You have things like solar power, vibration power. But what we're seeing is the advancement of the good old battery. So batteries are now lasting 5, 10 plus years. And it's not necessarily always the battery itself, it's also how these devices operate. So for example, you might have a temperature and humidity sensor. That temperature and humidity sensor has a battery that you can go buy at Walgreens, but the difference is that temperature and humidity sensor is a passive device anyway, so it's not pulling a lot of energy to begin with, but the battery will wake it up every 5 to 10 minutes. It'll sense the temperature and humidity, send it back to your hub or your building automation system, what have you, and then go back to sleep. So battery technology is advancing very quickly right now, and then also the way that we leverage those batteries is making a huge difference. And where we've always had to worry about, okay, I need to run a wire for communication, need to run a wire for power, you're now able to basically stick a sensor on the wall and it'll run for years without having to worry about that power element. So open protocols is another really big part of successfully integrating a lot of these systems that we're talking about. Open protocols in the building automation industry for HVAC control, at the very least, are BACnet and Modbus. So manufacturers are finally getting on the same page to some degree on using this common protocol. Now, without getting into it too much, I usually throw quotes around the word open when I hear open protocols, because despite the intention and at least the perception of open protocols, at times they can be guarded in their own ways. So just a word to the wise to understand what you're exactly getting into, but we're heading in the right direction, and it's something that is really customer driven. That is going to be a good thing, I think, for the Internet of Things becoming a reality. One of my favorite new technologies is actually an old technology made new, and that is power over Ethernet. So your classic Cat5, Cat6 blue cable that you have running throughout your buildings, that historically has been used for communication only. Well, there are wires within that shield that allow you now to inject power. So where you were running a communication wire and a power wire, you're now only running that single wire for both. And a lot of these power over Ethernet devices are becoming extremely popular as a result. And I mentioned earlier, your lighting can become a node on your network. There are now lights that utilize power over Ethernet for that purpose. So at the end of this, like I said, we want you to walk away and have some idea of how to take your building, your campus, from smart to smarter. First and foremost, we talked about it a lot today, network infrastructure is absolutely vital. Whether that is a 5G network, a wired Cat5, Cat6 network, a Wi-Fi network. Having that infrastructure in place is going to allow you to leverage a lot of these new technologies. And then we talked about it as well. We talked about this as well. Working with your IT team to make sure that you define access and security for your building's network. So when you do want to implement these devices, okay, well, we need to meet these specifications per our IT department. We need to meet these security specifications, and these are going to be the ways that you're going to be able to access this. And then we have ensuring building BMS, ensuring your BMS is well positioned for the future. BMS is Building Management System, also known as Building Automation System, Energy Management System. But when you're investing in a BAS or BMS, there are a lot of things to consider, because you're likely going to be engaged with whoever the service partner is for the next decade at least. And they're going to determine, what kind of information can we pull in here? What kind of things can we automate? So making sure that your building automation system utilizes open protocols, considering what future technologies are coming along the way or are currently that currently exist, like wireless. Do they have the ability to utilize your network, your Wi-Fi, or your 5G, what have you, and then making sure that you have a flexible system. So if it's it may be HVAC only. Maybe you need to look at, okay, well, what can we do to integrate more? We want to be able to see a lot of this from a single screen. So how do we do that? And then finally, with your building automation system, one of the things that you can start doing is just collecting data. Like I mentioned before, the data piece of this is the first part. So even if you go and set up occupancy sensors in throughout your campus, and you record that data of, okay, this area is seldom occupied. I can put an occupancy sensor here that's going to trigger the lights, and that's going to save me a bundle, because now I'm not leaving these lights on for no reason all day. Or you have areas of your campus that very rarely get used, and all of a sudden you have an occupancy sensor go off after hours. That may be a trigger to your security team. Your security team a lot of times is they're looking for ways to minimize the space that they have to cover, because these college campuses can be very expansive. So utilizing technology to help them is going to be a step in the right direction. And we always talk about finding the right service partners, because we are a service partner, and we try to help people understand what we do. But ultimately, you want to let the experts be the experts. So if you are evaluating a new service, a new technology, you're likely going to be trying to evaluate vendors. You want to have conversations with them and understand what kind of partner are they going to be. Beyond the technology they're going to provide, is this somebody that I'm going to be able to depend on? And is it somebody who really understands the bigger picture of what we're trying to accomplish as an institution? And that's one thing I'll close with here is make this an institutional goal. All too often it's driven by facilities or it's driven by IT. But we talked about the benefits and the learning outcomes, and ultimately providing a more personalized, improved experience for your students and faculty. So it's that you think about whose interests this is in, and it's really everyone's. It's in the institutions as a whole. And I think taking that approach is ultimately going to make this a more successful venture. Thank you, APPA. Thank you, Eric, for allowing us to do this. This is phenomenal. We absolutely love these kinds of opportunities to share our knowledge with facilities managers.